Okay, this is from exercise 9, which is from our review pack for the paper 1 questions for this polynomials thing. This is dealing with some complex numbers. Um, we need to solve that equation there. Oop, jerk. And by solving that equation, what we're going to end up doing, so that says that a complex number, when it's raised to the 4th power, equals -4. So let's write down what that complex number would look like. So a plus bi to the 4th power. Well, binomial theorem tells me that that's going to be a to the 4th plus 4a cubed bi plus 6a squared bi, or b squared I squared, plus 4a and then b cubed I cubed, and then plus b to the 4th, I to the 4th. Simplifying that, I would end up with a to the 4th plus 4a cubed bi. Can't simplify that. The I squared becomes negative, so minus 6a squared b squared. This simplifies to negative I, so minus 4ab cubed I, and I to the 4th is 1 plus b to the 4th. So from that, what we need to do is we need to gather our common terms. So we need to get our imaginary terms and our real terms together. So these are my real terms. So my real parts are a to the 4th minus 6a squared b squared plus b to the 4th. And my imaginary parts are here, and I get 4a cubed bi minus 4ab cubed I. All right, so we know that this altogether has to equal -4. That's what the whole deal is. Well, if that equals -4, I'm going to write -4 as a complex number. So what that tells me is that my imaginary parts have to be equal and my real parts have to be equal. So I guess let's first focus on our imaginary parts, just for ease. So if I focus on the imaginary parts, 4a cubed bi minus 4ab cubed I is equal to 0. So that gives me 4a cubed bi is the same as 4ab cubed I. Well, I can just divide both sides by 4i, and I get a cubed b is the same as ab cubed. If I divide both sides by a and both sides by b, I get a squared is b squared. Therefore, a has to be plus or minus b. All right, so using those values and subbing that back into my equation here, I would end up with a to the 4th minus 6a to the 4th, because b squared doesn't matter if I use the positive or negative value. When I square it, it just becomes a squared, so that's fine. And then plus a to the 4th. Yeah, is that where we're at? That's where we're at. So if I do that, this turns into 4a to the 4th is the same as, again, this is equal to -4. We had that from there. So I end up with a to the fourth equals -1. And if why is that negative? That annoys me that that is negative. That can't be negative. Because I can't raise something to the fourth power and get a negative number. So that's going to give me... Oh, because I subbed in A instead of B. Silly Stoltz. This is actually my B term. I just made a mistake. I need to sub in. This is actually B. So B is plus or minus I. And if B is plus or minus I, then that gives me -1, +1, and A is I. So my first value is 1 plus I. If this is one of my roots, and it could also be -1 plus I, and it could also be 1 minus I or -1 minus I. These are the four roots, because if one of the roots is complex, then its conjugates are. So we just work around that way. Next, the solutions from the vertices of a polygon in a complex plane. Find the area of the polygon. Okay, well, the polygon it's going to form is going to be a rectangle. So, and each of these things, I'm just going to write 1 plus I, 1 minus I, 1, -1 minus I, and -1 plus I. So, and that rectangle that it forms, all we have to do is find the magnitude. And the magnitude of 1 minus I, actually the magnitude of all of them, is going to be the same. It's a square. They're all the same because their roots is going to be square root of 1 squared plus 1 squared. So that's going to be the square root of 2. So the sides of this rectangle are square root of 2 times the square root of 2. So that should just give me 2. I think that's the right answer. That would make sense to me. Yes. All right. I hope that's helpful.